So in this video we come back to a diode diagram that I put together. So all you can see here is the schematic for the rectifier diode. We're also got LEDs on here. They have arrows coming out of the same schematic symbol on either side, doesn't matter. And then also the Zener Diode. It has a couple of lines that kind of looks like a Z to indicate Zener. But to begin with, we're going to look at 4 rectifier diodes here, and this is a full wave bridge rectifier. And what it does is you can change the polarity across the circuit when it comes to power. Of course, loads like LEDs need the power in one direction. There's light bulbs and stuff that can work with current going both ways, but we don't really use light bulbs anymore. But the LED needs current going in the same direction. Also, household power alternates current, but don't mess around with that. There are these adapters here. They take the alternating current and they rectify it for you. They already have this in there, and also they lower it to a usable voltage. This one is adjustable. But in any case, you'll probably see this a lot, and you may still have to do stuff with circuitry that follows this. So especially when you got like alternating current like the household, it goes up and down over time. So even though the power coming in is changing direction, it's being applied in the same direction to the load. It's going up and down instead of changing directions over time. But in any case, I have it wired here like that. I'll yank the load real quick. We'll look at that. I did put the LEDs in the opposite direction of what you see here. I thought about wiring it exactly like this, but I have it wired more how I like it there. And that is one thing that you got to be aware of. The schematics are just a guide. You look at the connection points, see how it works and whatnot. You can make modifications as needed. You can use different value resistors or whatnot. As you learn more, you can make different modifications. The main takeaway with this circuit here, you can see that these two diodes are connected to each other. We removed the load. Their anodes are connected to each other. On this side, the cathodes are connected to each other. So I just swapped the sides. That anodes are connected and cathodes are connected. You can see here, looks like the light's pretty good in this spot, that we got the gray stripe away from each other with those two, and then the anodes, the gray stripe is the cathode, the anodes are connected directly together. They're offset by one spot. With these, there's no connection there. We got to connect with components. But here we have the anodes facing away from each other. Cathodes connected to each other right there. And then the two sides of the LEDs, they're connected on both ends, as you can see in this schematic. So I just swapped the directions there. But the main takeaway is, now we will attach the load. So I'm going to grab the LED first. And so again, the LED is a diode, just like these diodes. And so the anode is the long lead, the cathode is the short lead. And so we can run positive here through the LED towards negative that way. And then same with these. We can either go that way or we could either go that way, as long as one side or the other is more negative. So we have a flow either that way or that way. The resistor here, it's a 1 kilo ohm resistor. I'm using 1 kilo ohm resistors for everything except for this is a 510 ohm resistor. And in case I forget to mention the values again. But in any case, that goes to where these two diodes are. So we already talked about these both head towards negative no matter what. And they block positive from coming into it. Over here, these allow positive to come that way. And they don't let negative come either way. They're both set to go to the positive working that way, through the resistor, through the diode, and then to whatever other side is more negative right there. And now we can zoom back and look at that, and we'll have this on there. So usually I work my way positive down to negative. So we got that jumper there to the positive rail, and we can go anywhere along this node, wherever these components all connect. That's a node. If there's a direct 0 volt connection between a bunch of components in one spot, that is what's called a node. So there you can see it lit up. Now of course when you apply power to an LED in the opposite direction, it does not light up, but we won't actually be applying the power in the opposite direction to the LED. It will be to the 4 resistors, and so they will divert the current so that the LED still lights up. There we go. And so in any case, you don't usually build this. There's adapters that do this for you, and there's also this component here. There's 4 diodes within here. It is a full wave bridge rectifier component. So you can see the little swiggle lines. That's where you apply your changing voltage, and you can see plus there. That's going to keep outputting plus. It's a longer lead. That side's going to keep outputting negative. So that is the indicating the 4 nodes that you see there where the diodes connect on the 4 sides. And so that is the full wave bridge rectifier. Again, you'll see it a lot. You may have to build circuitry that responds to it, because especially if the voltage is changing over time and whatnot, but for the most part you won't be building this, but it's good to be aware of it. And I did draw the arrows if this helps too. You can see that diode, if this is more positive, the arrow points the direction of positive to negative, and then hopefully the load lets it go through. But then you can see that one is pointing positive, heading that way if that's more negative. If this is more positive, that arrow's pointing that way, going through there, and then this arrow's pointing over there. If you want to look at electron flows, electrons go into the cathode and out the anode, you know, so you can do that too. I drew those wires. But anyways, it's just easier with the arrows to look at how positive is going to negative. So now next, I think we will go to the polarity indicator, and we got a couple LEDs down here, and so we're going to swap which direction the power is, but we're going to grab a 1 kilo ohm resistor, and so we got the red LED. I usually work my way down more negative, so I'm going to put the long lead, the anode, down right there. It actually doesn't really matter. Short lead cathode is up 1 row. We're going to do the opposite with the green LED. So the long lead, the anode, is going to be up 1 row, the short lead, the cathode, down 1 row. So the anode and cathodes are connected to each other. They're not anode to anode, they're anode to cathode. And then we will take the resistor here and put it to the top row right there, and to the top of the LEDs there. And so one's one way, the other's the other way. Now, like I said, I usually work my way more positive from the left to more negative to the right. So we'll put that jumper to the positive rail, and this one to the negative rail. Jumpers don't have polarity, but it's a good idea to color code them. So there you can see the green LED is lit up, and that is what we have here. You can see we got positive. Again, those arrows point the arrow of the schematic, not these arrows. They're indicating lights coming out of it, but the arrow of the diode schematic points the direction positive, works its way towards negative when it conducts. So that one's going to block it. And so we only got about 3 volts built up across that LED. We actually have 5 volts at the supply right now. I'll raise it up to 9 volts really quick. We can do that. It's a 1 kilo ohm resistor, so we got plenty of resistance. And so there we go. We got 9 volts, and it's still protecting it. So I just did that because I wrote 9 volts on there. Again, you can modify as needed. Now we will slide this over, and I have the same schematic, but now the positive is on the right side, the negative is on the left side. So let's pluck that, and now the other LED will light up. Make sure we put that to negative, and then this one to positive, and the other LED will light up. So as long as you know what the color means when it comes to the direction of current, you can tell. Now, if both of these look like they're on, and you know you wired them opposite direction of each other, it's impossible for them to be on at the same time, but they can look on if they're flashing back and forth fast enough. And so that's really easy to do, to get them, I think, like 15, if you change the direction like 15 times a second or something, they start looking like they are both on completely. They won't be as bright, but in any case, if you know you wire it properly, they both look like they're on. That means that the polarity is changing very rapidly. And finally, we come to the Zener diode. So, the Zener diode, it's a good thing I drew this right by here. The Zener diode works differently. You'll probably notice this is reverse bias without a forward bias diode next to it, like the Polarity Indicator. We do not need this anymore. It's just kind of a distraction. So, the Zener diode works completely differently. It will conduct forward bias like other diodes, but that's not how they are intended to be used for the most part. You reverse bias them. So if you put enough voltage across the diode, well, reverse bias the direction that it blocks voltage and current. If you raise the voltage enough, sooner or later it will start conducting. I didn't mention this in the last video. There is a blue line right here. This is what an ideal diode would do. If you give it any voltage at all, forward bias, you would hope that it would conduct. But unfortunately, no diode is perfect. It will block a little bit of voltage. If you reverse bias it, you want to give it whatever voltage you can and it will never conduct. That's an ideal diode for a rectifier diode. The Zener diode, you actually select a voltage. They come with voltage settings, so that's why this bag has 5V1 on it. So that means 5.1 volt. The Zener diode I'm using is rated for 5.1 volt. Well, reverse bias, it will start conducting at 5.1 volt, and it's safe for it to conduct. You still have to limit current through it. It has, I think, a half a watt rating. I'm not sure though, but has a wattage rating like everything else. You have to limit the current going through it. Now you also got current going to other circuitry. So in this case, it is this resistor and this LED. So we have this schematic here. I drew this in, I don't know what you would call it, kind of the more box formation. Instead of a battery symbol, I use V for a voltage source. That side more positive, that side more negative. And it has to be a fair amount above what the Zener voltage is. We'll look at that. The Zener voltage is kind of like a release valve to hold a voltage, but you want a higher voltage coming in. Now, so I drew it kind of in the box form. This ground symbol is not needed, but a lot of times you'll see it, so I wanted to mention that right now. I think there's software. A lot of people draw their schematics using software, and I think there's software that demands you indicate where the ground symbol is somewhere, and that's how you do it. You plop in a ground symbol somewhere. So you'll see that, and just indicates that this node, that conductive area, is your 0 volt reference point. And so hopefully that clears up any confusion you may have. Oh, also Avalanche, for now it's really the same thing as Zener. If you see Zener Diode or Avalanche Diode, it's working on the same principle. The Avalanche Diode though, you'll see it probably written a lot and probably not deal with it. It'll just be a Zener diode. But in any case, we have this here. So let's see what it is doing. We rose the voltage to 9 volts with the power supply, as you can see here. For whatever reason, I just decided I want that LED and its protective resistor to have no more than 5.1 volts across it. So again, when you put more current through diodes, they tend to block a little more voltage, but for the most part, it's relatively steady. So we're going to look at the voltage first at the rail right here. So I'll go up here, or I could go to where the resistor connects. So again, we are still at 9 volts there. Now we're going to go across the LED and the resistor right there. And there you can see 5.1 volts right there. So the rest of the voltage, or actually the voltage builds up across the Zener diode. And again, remember, it's reverse bias right now. So the cathode is towards the more positive side. That is the black stripe. This is the last video I did and whatnot. We used LEDs and rectifier diodes, these black ones. There's also glass rectifier diodes and other type of diodes, and I think all the Zeners I saw for the most part are glass like this. So it's glass, there's a black stripe for the cathode instead of a gray stripe, but it is reverse bias. That is the main takeaway. we're taking advantage of when you get enough voltage, reverse bias, for it to start conducting. And there's a wide range of values you can choose from. But in any case, it's kind of like a release valve. If the voltage tries to go above 5.1 volts, it passes more current through that diode. So we got positive going over there. So hopefully you can see that right there. And then the rest of the voltage. So this is a 510 ohm resistor because I didn't know how high a voltage I was going to go. But we have to be careful when we design this and whatnot. I didn't put values on here. And so we can look at the voltage across the resistor, which should be 4 volts. Because we got the 5 volts there going that way, 5 volts going that way. The rest of the 9 volts should be across this resistor right there. And so we got 4 volts. So when you're designing it, all the stuff I just showed in these last videos is stuff you use, that Ohm's law and how the voltage gets split up among components and all that. Once you have a good understanding of that, it's really easy to select values of components. And so the 510 ohm resistor can go up to about 10 volts relatively safely. We only got about 4 across it, which is a lot less voltage than its maximum amount. And so in any case, that's really it. Hopefully you enjoyed the video, and these 3 circuits are all pretty common in electronic circuits. Again, the rectifier one though, you may just go without ever having to build one at all, but it's a pretty cool circuit. But for the most part, everything's already rectified and everything. But that was the main purpose of these rectifier diodes, for alternating current being turned into direct current, but then usually it's a high voltage that it's dealing with and whatnot, and you have to smooth out those up and downs. That'll be capacitors later. But in any case, you don't really build this one, but I do a lot of polarity indicator. I took it down, polarity indicator circuits in my videos, because a lot of circuits have change in polarity, and this is a good visual for seeing that, so I'd like to do that. And then the Zener diode, there's a lot of voltages where, or a lot of circuits where you want to set a voltage, and usually you don't power the load with that. That'll be transistors. We'll look at that. You can set a voltage to a transistor, and the transistor will do a better job of holding that voltage. But in any case, the Zener diode is a really good way, really simple way, if you have a bunch of values, to set a specific voltage at a point. And so you're going to see these concepts a lot. So I included them in the circuit fragment videos because they do their independent thing, but they affect other circuitry. So they're very important to learn to understand more advanced circuits. So thanks for watching. I will see you in the next video.